So welcome and thank you for coming to our sessions. So our afternoon session and somewhat the last session of the day, not exclusively, but in this room, it will be the last session of the day. So as I said, we have a lot of content to cover. We will take questions after the session. We'll be here until they kick us out, and we will walk out the door with you if you need to, and we will stand there. But sessions will take down there, so we don't need that microphone there in the middle. Welcome to Best Practices for the most impactful Oracle database HA features in Oracle Database 12c, 18c, and 19c. If you have come into the session because you followed the title on the session catalog, you may have noticed that it is slightly different. The marketing reviewers have done two things to it. Once they have said HA no one understands. Is anyone here in this room that doesn't understand the abbreviation HA? Thank you. You probably wouldn't have admitted, but that's exactly the reaction I hoped for. So anyway, they removed it because it wasn't clear enough. They also removed the versions and just said 18c and 19c. It's technically correct, but as you probably know, 12c, 18c, and 19c are basically all the same product family, I would call it, for the lack of a better word. So we will touch on a few 12c features, particularly 12.2 features, and 18c and 19c, just so you know which features we will be talking about. Because when I created the slide deck and I realized I have only 45 minutes, and then Mauricio will also want to talk, I said, okay, which features do I choose? So I narrowed it down to HA features. With that said, as I am at least part of the product development, I have to show you the safe harbor statement. I think it's not entirely new to you. Maybe you've noticed we have a black version also, but other than that, you should know the content. What features are we going to cover today? If time permits, we're going to talk about Oracle Multitenant and Pluggable databases. Now, some of you may wonder why we would talk about Pluggable databases in the context of high availability solutions. And if you wonder about this, please remain seated. We will also talk about some inherent database features that will be rather brief. I'm going to call out one in particular, which is the Hang Manager, Database Hang Manager. Anyone familiar with Database Hang Manager? That's clearly the minority and typically what happens. And obviously, we didn't have a product manager at the time this feature was named, because otherwise that feature would have a different name, but we'll come to that later. Active Data Guard, that is perhaps one of the more known features. We'll be talking about Data Guard as well as Active Data Guard. That's why the first adjective is in parentheses. And last but not least, for those of you who have seen me before, real application clusters will be talked about rather briefly, and Oracle Sharding. And I did notice, even though I showed you my employee badge, that I didn't really say who I am. So my name is Markus Michalewicz. I'm the product manager for Database High Availability and Scalability Solutions. And today, I'm on stage with Mauricio Ferreira. I hope I got that right. We trained this before. So he's a consultant, Oracle consultant. He has his own company. And he will be talking about two of his customers who have implemented some of the features I just walked you through and what they have done, MiBanco and Banco de Bogotá, but more about him and these customers later. Let's go and talk about Oracle Multitenant and Pluggable databases. And as I said before, you may wonder why I would bring up Pluggable databases as a high availability solution. And the answer is rather easy, because Pluggable databases are an inherent database feature. And if you had followed what happened and what was announced during Open World this year, you may have noticed that, obviously we made it easier for you to adopt Pluggable databases, but we also have come a step closer to Pluggable databases be de-supported. So one way or another, you may want to look into Pluggable databases, and as you have to or want to do so anyway, it would be one way to look at them as a database high availability feature, because Pluggable databases enable quite a few common lifecycle operations in an online fashion. I will walk you through three of them, but there's a lot of lifecycle operations such as moving databases, moving data therefore, that you need to perform on a daily basis, and Pluggable databases provide a perfect solution to those. Last but not least, they're integrated with other Oracle high availability HA features. So if you have these lifecycle operations, they are also integrated with your disaster recovery, with your high availability solution, so you don't have to worry you lose HA while you are moving your databases around. So with that said, in 12.1, we introduced Pluggable databases as a container-managed database virtualization solution. Some of us may have said they are a consolidation solution, and they were featured by saying, well, you can manage many as one and you can provide software as a service. All of these aspects are still true, but from an HA point of view, the real features that I would like to talk about came in with 12.2, hot clone and refresh, incremental refresh, relocation with no downtime. These are features that in the context of high availability, I would care for a lot, and they have been introduced with 12.2, and then they have been advanced later on in 18C and 19C. Transportable backups, snapshot carousel, and refreshable PDB switchover are some of those features, but I'm not going to talk about today in detail about those. Now, what is PDB Hot Clone? As the name indicates, it's a way to clone a PDB that is residing, in my example here, on premises in a CDB that has 3 PDBs, online or in a way that you do not interrupt your application. So the example here assumes you have 3 PDBs, pricing, retail, and CRM, and the intention is to move the CRM PDB to a test and dev system. So instead of moving it, what we want to do is we want to clone it to a test system. In my example here, that test system is in the cloud. It can be anywhere. It could be on another system, anywhere you want. And the idea is to say, okay, I can now move a clone of my CRM PDB while the CRM application on the CRM PDB is still in operation. So you do not interrupt production once you move or while you move your PDB clone to the other CDB. And once you are in the other CDB and you have that full clone, you can then use snapshot cloning to create one or n more pluggable databases to give those to your test and dev systems. So this is an easy way for you to create a test and dev system for your applications online. There is no interruption to your production environment. Now, if you extend this idea, you will see that, of course, as time progresses, the CRM application continues to operate on the production database. Now, if your intention is to provide your test and dev environments with a constant update to the data, Oracle Pluggable Databases has a solution as well, because as you make changes, you can either incremental refresh or clone with the latest data. So either way, what would happen is you would get a fresh set of data into your clone, as just shown. If you missed the animation, I'm going to show it to you again. And then your base clone in my example, in the cloud has been refreshed, and you can therefore create new snapshot clones for the dev and test systems as previously done in the example. Again here, neither production system nor the test dev system are really interrupted by this operation. There may be a little bit of interruption on test dev, but for the most part, it's actually very transparent to both sides. Last but not least, there could be a scenario in which you have an environment on premises or again in the cloud, and you want to move one of the PDBs to another CDB for logical reasons. In this assumption here, we would say we have pricing and retail and CRM in my formerly mentioned CDB on premises. And now the idea is to say, well, perhaps we want to move the CRM PDB closer to the HR PDB, which already resides in the cloud, and those two should perhaps be residing in the same CDB. That's what this example shows here, and you can do this move online pretty much as I showed it. So you take your CRM PDB, move it to the cloud next to the HR PDB in the CDB, and then you switch it off on premises. Again, that is a relocate that PDB is allowed to be online. So if this is a scenario which you can foresee in future you would want to do with your data, PDBs have a solution that's inherent to the database. Now, as I said before, PDBs are also integrated with our HA features. In particular, there are multiple replication capabilities for PDBs, although it's de facto only 2. You can either use DataGuard or Golden Gate. And as you use either DataGuard or Golden Gate, the implication of the replication are as you probably know it. So if you use DataGuard, what you will get is a full block identical copy of the CDB, I must say, of the CDB to the standby server, here in my case server 2. So we have server 1 hosting the primary, 4 PDBs in it, and then we have server 2 hosting the standby. And as you can see, only 3 PDBs are in it. There the assumption is that while we are taking a replica via DataGuard of the full primary, there is a choice for you not to apply the redo for individual PDBs. However, the redo is being transferred to the standby server, just to be clear about it. In a future release, we will have a per PDB data guard solution. We are working on this one, but unfortunately that one has not established itself yet. Now, if you need this, if you do need a more individual or flexible way of choosing which PDBs to replicate between your primary and your standby, then Golden Gate may be your solution. Maybe because Golden Gate does not create a block identical copy, as you probably know. So if you had the idea, for example, to take backups of the server 2 from your CDB, that wouldn't be working with Golden Gate. On the other hand, you are way more flexible in the type of replication that you can choose. You can, for example, choose to replicate from server 1, CDB 1, which is somewhat the primary, but you can see here you can also go the other way around and say PDB 3 residing in server 2 should be replicated back to server 1. So it's bidirectional, it's more flexible. That would be the advantages of Golden Gate. You can also combine the two if you so want, and as you probably know. PDBs are not only good for the lifecycle and the replication, they also help in Oracle Real Application Clusters environments in two ways. There's more ways, but two I found most important. One, and both of them are related to isolation. So as you recall in 12.1, PDBs were introduced as virtualization solutions and consolidation solutions. And in 12.2, we therefore introduced two isolation features. One isolation feature helps with preventing noisy neighbors from affecting others with unnecessary chatter. To me, to be more technically correct perhaps, and I see the grumpy face of Andre Gusev there a little bit when I said this, so I make it a little bit clearer. What we can do is if you have singleton pluggable databases, we will exchange messages only between those instances in which the PDB is open. So in my case here, I have 4 singleton PDBs. One, the orange one, right in the middle there, is open in both instances. If you have such a scenario, RAC and PDBs will make sure that we only exchange messages for the PDB that is open in both instances, so we wouldn't necessarily communicate more than absolutely required, because we know that the other PDBs are not open in the other instance, so there is no need for updates. On a similar thought, if you then extend this idea, in case of a failure, we would isolate singleton PDBs from being affected by other PDBs and instances failing. So in a concrete example here, if I have the same layout, and I have my instance on node B failing, and I had only singleton PDBs in both of them, the ones remaining on node 1 would be unaffected because there is nothing to recover. RAC and PDBs would know that there was no open transaction on the singleton PDBs. So if you would like to choose PDBs and real application clusters to consolidate, don't be afraid. There will be protection, and you would not need to worry that there will be overhead in communication or failure impact. As we think that PDBs become very important, we have also introduced, or we will introduce in 20C, 2 new features actually. One is a first-class PDB resource, and then the second feature resulting from the first one is an automatic placement of PDBs. Let me first explain the first-class PDB resource. As some of you may know, in current versions, the placement of PDBs is indirect. Indirect by means of you need to use you need to create and use a database service to put the PDB, meaning to say to define where the PDB is open, in which instances it is opened. In 20C, you will be able to actively work on a PDB resource, so you don't have to use a service. You still want to use a service for other means, but the placement of the PDB resource will be direct, and you can say, okay, I would like to have my slightly bluish-gray PDB open in that one instance, but not in the other directly by operating on the PDB instance. At the same time, we will provide you with an automated placement. Some of you may be familiar with the concepts of policy-managed databases and admin-managed databases. Who is familiar with policy-managed? Excellent. Policy-managed databases allowed us for you to provide policies that regulate the startup and stop of PDBs, for example. So you could have set up policies to define which PDBs will open in a consolidated environment first, which one will go down last because you think it's most important. And in general, policy-managed databases would have allowed you to automate the placement via cardinality. And a lot of our customers like policy-managed databases, except for the part where the operation on those resources would deviate from the admin-managed style to which they have been accustomed for 20, 30 years. Now, in order to accommodate both requirements, having automation and flexibility, and to use the admin managed style, in 20C we will have a cardinality-based approach to put, for example, PDBs. That approach can be extended in other areas. But the idea is to combine the policy managed and database admin managed management approaches so that we preserve the goodness of the policy managed approach, first man up, last man standing, and placement in general, and at the same time give you a means to use the admin managed style as far as commands are concerned. So I think this will be rather interesting for you, and you should be looking at it when 20C comes out. Now with that said, a feature that is much older than either 18C and 19C for that matter is Database Hang Manager. As a matter of fact, Database Hang Manager has been introduced in 11.107 by a MOS node, and in hindsight I would say that was rather a mistake, but it has been out there ever since and it's very useful and it is enabled by default. So if I ask you whether you know it, I did so because you may not know it that you use it, but it is on by default. And what it does is it detects hangs. Now we want to be very clear here what type of hang I'm talking about. It is a hang within the database, or more precisely also between layers that the database uses, such as ASM and the database. And I think Hang Manager is a perfect solution because one of the most trickiest things to do is to detect and resolve a hang. And why is that? Because detecting a hang is very difficult if you think about it, because you never really know whether it's hanging or it's just slowly progressing. A deadlock, which we also take care of since 18C, but we have been taking care of deadlocks in the single instance databases and RAC for the longest time, just now Hang Manager does it along with other things. Deadlocks are actually very easy to detect. If you look at a process graph, a deadlock process graph is always a closed graph, so you can really easily detect those. Hang is always an open process graph, pardon me. So in order to detect whether the processes in that graph are hanging, you would have to look at the processes progressing over a period of time. And that's what this flow diagram is actually showing. So the way Hang Manager works, and I make that rather quick, you will get more slides with details if you download this one. There are links to more detailed slides. Hang Manager goes in and says, I take a snapshot of the processes every once in a while, 3 times, and I see whether these processes have been progressing. If we determine a set of processes that hasn't been progressing, we do the same thing again. We take 3 snapshots over a period of time, see whether it has moved, and then we confirm or either deny our suspicion. Once this has done, we run one more thing, the verify, and then we say, okay, this is clearly a hang, and well, we should be killing the root cause, so the session that is causing the wait. You can call him later. So now that we do this, you may understand that there is a certain amount of time that Hang Manager needs to actually detect and consequently kill the hang. And right now it's around about 95 seconds. Don't correct me, guys. 95 seconds. Now the other thing that you need to consider is, well, whether to detect a hang or not depends on the state of your system. Think about it this way. If you have an idle database, slowly progressing processes are likely a hang. If you have a database or a system that is highly utilized, so you have a lot of workload being running on it, slowly progressing processes may not necessarily be a hang. But in order for us to determine this, ever since 12.2, Hang Manager actually auto-tunes itself. So it recognizes what the system is doing in order to give a more assertive answer to whether or not something is a hang. Now, if you say, well, this is all good and nice, but I really want to have the hangs being resolved sooner than the formerly mentioned time, then we give you this opportunity by setting DBMS Hang Manager.Sensitivity. Starting in 12.2, you can set the sensitivity from normal to high, and then it will be a little bit relaxed on the verification. So you may see Hang Manager act a little bit sooner at the cost potentially that we are killing a process that isn't really a hang but very, very slow in progressing. I'll leave this up to you what you prefer. There are some customers who say, well, I much rather kill than wait and just resume the operation. And if you have other pieces in place, such as application continuity, which you heard about this week, I hope, that may be the right approach. Now that said, You can set this sensitivity, and Hang Manager will always protocol when it acts in respective log files in the alert log and in a trace. I have a slide on this hidden here. If you download the slide deck, you'll see it. Now, for the other inherent database high availability features, there's actually only two that I would like to name. The one is online operations, particularly those that can be used with the DBMS redefinition package. And I don't want to go into greater details on that, except for the part where I'm saying Oracle has always been very keen on making sure that a lot of changes you may have to do to your schema, so inside of the database, can be performed online. And in 18.1, we kind of reached the state where we say most of the operation that we think and you told us are necessary, we have covered. It's not to say that all of them are covered. There's always one more to desire. However, if you wondered why there wasn't any new updates on online operations in 19C, it's because we have actually established a very good set of online operations. So whenever you need to alter a table, move a table, a partition, or other objects, we can do this most likely online, and the Oracle database is one of the very few that actually enables to do so. The other area of high availability has nothing to do perhaps with changes, life cycle, or failures. Has more to do with the fact that however good we think we are prepared, our applications or we ourselves may perform not ideal, and that means we make a mistake. That is perfectly fine. But the problem with those mistakes is that they sometimes end in logical errors, such as wrong updates or data being updated where it should not have been updated, like people all became a VP in a company. While this is probably very good for the people, perhaps not so good for the company. So if these kind of things happens because either your application made a mistake or someone pushed the wrong button, Flashback Technologies in various forms help with this. You can back out transactions, you can correct incorrect table updates, or you can even rewind the full database. However, this would require that you enable Flashback a priori. That means you need to explicitly enable Flashback, which results in the allocation of Flashback logs. So in order for you to get all of these benefits here, you need to enable Flashback, need to allocate Flashback logs, and then you can benefit from the feature at the time it is required. You can read up on it. It's a rather old feature. However, it is constantly being updated. So the last changes to Flashback are mainly in the area of integrating it with DataGuard, for example. If you have seen Peter's DataGuard session earlier this week, you may have noticed that it's fully integrated now with DataGuard and will be continuing to integrate these Flashback technologies accordingly. Now, speaking of which, Active DataGuard is probably one of the more known and expected features in the context of high availability. And the first thing that I want to do is I want to clarify what exactly is the difference between DataGuard and Active DataGuard. I'm sure you're all aware what the difference is when you want to use one or the other and you want to perhaps use it for some reason. The difference is Active DataGuard is an option. That is a nice way of saying you have to pay for it. And DataGuard can be used without you sending the credit card to your account rep. So now that said, this is DataGuard. This is the simplest form of representing DataGuard. As I said previously, in the context of PDBs, DataGuard creates a block-identical copy of your primary database. Whether that database is non-CDB, CDB, it doesn't matter. We will take whatever is there and replicate it over to the DR center in a block-identical way, which means you can take backups on your standby side and apply those backups to the primary if you needed to. Included in DataGuard itself is also the operation with DataGuard Broker. There's always some exceptions, but in general, anything Enterprise Manager Cloud Controller DGM GRL gives you is included here. Now, what's the difference then towards Active DataGuard? The red bubbles basically demonstrate them, and I will walk you through some of them. The first one right bottom there is automatic block repair. This is a very cool feature. I don't know whether you've ever seen it. There's a demo on our website. If not, it will be after my session. And basically what it does is if your primary database runs into an error that is caused by either a corrupted block or block missing, whatever it is, if you have Active DataGuard, it will request that block from the standby and automatically apply it in a recovery process to the primary. So the moment your application or the database on the primary side hits this error, you obviously get an error message back. However, if the next action your application would take is a retry, If you have active data guards in place, the retry and reading that block should have happened perfectly fine. So this is where active block recovery or repair is a good feature. The other part which active data guard gives you, that is perhaps more like a licensing option. It allows you to use what it's called fast sync. Fast sync can be thought of as a repeating instance, so it takes the read logs from the primary closer to the primary and then ships it off to the far further side. The idea is here that between the primary and the fast sync you can use synchronous apply as opposed to asynchronous when it goes further distance. So if you have the requirement to use data guard across bigger distances, fast sync would be a solution, although Mauricio will be talking about a very interesting case for fast sync to cover network outages, or not outages, but glimpses or hiccups later on in his two examples. Now, what has always been the feature of active data guard is the fact that the standby side is actually open for reads, so you can put read-only workload on your open standby. Well, that is until 19C, because we have an enhancement there that you can actually do upgrades on your standby data side. The feature is called DML, data manipulation language redirection, but really what it means is that you can issue any DML on your standby, and the way it would work is you would have your application run on the open active standby database. It would issue a DML. That DML has been transferred to the primary. There it will be applied. As soon as you apply the DML on the primary, it generates redo, it goes back to the standby, it will be applied on the standby, and the transaction closes. The whole transaction is ACID compatible, so you're not losing any ACID attributes here. The only thing that you need to consider is that as we are shipping the information twice over the network, we would probably recommend you use this only for occasional updates rather than running your OLTP on the standby side. A typical scenario would be you have a report running in the end of the month, and in the end of the month it writes a summary. Well, that summary can now be written on the standby. You don't need to have that moved to the primary. This feature can be enabled either completely for the database or on a per session basis. The last area I want to talk about before Mauricio gives us some examples is real application clusters and sharding. And the reason they are coming together, even though they are quite the opposite of solution, is because they provide high availability and scalability just by very different means. And I will start with RAC, and the main message that I want to convey for Oracle RAC is that we have actually established with Oracle Database 19c a RAC for a new generation. What do I mean with this? As you probably know, Oracle RAC has been out as long as I have been with Oracle. That is approximately 20 years, plus minus one who is counting. And over the time, we have constantly improved RAC. However, there has been feedback for more than one of you that perhaps the management of RAC wasn't that ideal in 9i, 10G, or 11G. And also, performance and scalability, as well as high availability, could have been improved for the latter in means of, well, if something happens in the cluster, there is a cluster resynchronization time, or often referred to as downtime. Well, that downtime, we strive to be zero, and yet we haven't reached it yet, although we believe that in these respective versions as listed here, we have established a very good milestone. So we believe with various tools that in 12.2, we have reached a very good manageability of RAC. If it's not by generic use on the very engineered systems or the cloud, it would for sure be the case. However, even if you use it on generic systems, features like rapid home provisioning, nowadays called FPP, and even features within the stack help to manage it. I'll give you two examples later on. For scalability and performance, we believe that with 18C, we have actually reached a best ever scalability and performance level, and I'll explain why. And so for high availability, although for high availability, we would be recommending 19C, and you will see in a minute why that is. Coming back to why we think we have established management perfectly with 12.2, well, one of the reasons is we have multiple ways of providing gold images. Secondly, we have started to introduce the zero downtime patching, grid infrastructure patching. That is after 18C, or with 18C. As you know, when you do a when you do a grid infrastructure rolling patching, you can always roll it. The problem was that as you do so, on the node on which you are applying the patch, you have to take down the database instance. With zero downtime Oracle Grid Infrastructure patching, you don't have to take down your database instance on the node on which you are rolling patching the GI infrastructure. Now, this feature was first introduced with 18C on Linux, obviously for RAC databases, and was somewhat limited to certain patches. In 19C, we have enhanced the number of patches we support, but more importantly, we made it generally available with fleet patching and provisioning, FPP, or as I said, formerly known as RHP. And then in 20C, we will make it generically available, and we will cover the RUs and RURs as long as you are on Linux and have a RAC database. You can then combine this feature also with another feature coming up in 20C, which is Oracle Grid Infrastructure Switch Home. And a lot of you have asked for this because it basically does one thing. It says, I have a home of a grid infrastructure. Here is my other home, which has the desired version. I would like to upgrade this home within the desired version. Why can't I just take this home, the new home, and switch it over to where the old home was and continue to run? That's basically what it is. It's probably a little bit simpler described than it will work, but there is an O-installer switch home operation that does exactly this for GI. For the database, similar things have been in place for the longest time, specifically with read-only Oracle homes. Better scalability and performance. If you had seen my session last Open World, you may have seen a similar version of this slide deck. Bottom line is that we believe, and on Tuesday I spoke about it as part of the Ask Tom session, bottom line is that we believe that RAC scales most of the applications out there with no problem. Now, if I was to ask, and I will not for that reason, who has seen an application that doesn't scale here? Well, there's probably a few people that will raise their hands, and that is perfectly fine. Now, among those applications that didn't scale as expected, so anywhere between 80 and 90% across the system, the reason why it didn't scale is often related to due to a high contention workload case. That doesn't mean the whole application causes this, but you had a high contention workload case, meaning to say you may have had a high contention in your application, and that would have slowed down your application as such. Normally that is the case for these applications that didn't scale that well. Now, if you had seen my Ask Tom session, and you can download it from my SlideShare next week, you know that we have done various enhancements to tackle this case. We have introduced a whole bunch of new features, some of which I have listed here, and some of which are actually related to Exadata. But even if you are not using Exadata and RAC on Exadata, as soon as you go to 18C, more precisely perhaps to 19C RAC, you should see an improvement in performance up to 5 times if you had experienced a high contention workload with your application in either 10G or anywhere before 11.204 or with 11.204. One of the features that we have introduced on Exadata is RDMA read. We will have an RDMA buffer cache read, an undo RDMA read with 18C, and we will have a buffer cache read via RDMA with 20C. So on Exadata, we will continue to use the fast network, the bandwidth, and the direct access to memory going forward. But for those of you who are not on Exadata, as I said, there's a bunch of other features which will help you to improve performance as demonstrated here. So if nothing but, you should perhaps upgrade to Oracle Database 19C. Now, why would I say 19C even though it says 18C there? That's because of that one here. We have established a best-in-class availability, so we think, between 11.204 and 18C, but we are still working on it. So even though this has been established with 18C, and when I say this, we have reduced the downtime that comes through a cluster reconfiguration. So when an instance fails, we have reduced this downtime by 4 times between 11G and 12C, and another 1.5 times between 12C, the numbers are up there, 12C release 2, and 18C. So if you're a little bit easy with the math here, you would see that we have improved by 6 times, and that is also due to a bunch of new features, which I can't go through, but my last year's presentation will have these features. And in 20C, we will do even better. We will have a fault-tolerant cache fusion, which covers the last cases in which the network may not deliver messages or not in the expectation we had them. So there are some hiccups that we may encounter internally, and we will tackle those even better. So we will have a more tolerance to hiccups on the network, for example, so that shouldn't be causing any problem for you. We will also have zero brownout for plant maintenance. That is an extension of the reduction that you can see here, whereby this reduction here is for unforeseen incidents. With that said, the last 3 slides I have, and then I will lead over to Mauricio, is on Oracle Sharding. Who has looked into Oracle Sharding here? Oh, that's okay, don't feel bad about this. This is clearly the minority, 2 people. Yeah, well, what shall I say? Oracle Sharding is a good solution if you have one of those new generation applications. And what do these new applications want from you? They want near linear scalability or linear scalability, extreme availability, and perhaps or geographic distribution. So if you have a use case in which you need to ensure that you really scale linearly, whereas RAC will scale nearly linear, and you have the requirement that your databases can be distributed across geographic distances, so over some bigger distance, you may want to look into scalability and extreme availability via sharding. Now, how does sharding and RAC compare? Very simple. Sharding is basically shared nothing, except you can then base it on different databases. And the idea is very simple. In Oracle RAC, the database system tries to get the data to where the application is connected. In sharding, it is expected that the application can be altered and modified to understand that you are operating on a sharded database, which are independent databases in the end, and then go to where this data is residing via a sharding key. And as long as you can modify your application accordingly, you will basically get guaranteed linear scalability and extreme availability, and if you so want, geographic distribution. So there is a perfect use case which DataGuard and RAC in consumption or together cannot tackle. However, there is a requirement to have your application sharding aware. For Oracle, sharding has been introduced in 12.2 and has been enriched with a bunch of features ever since, as you can see here. Now, we wouldn't be Oracle if we wouldn't have done something special to the old concept of sharding. And without going into great details, because that was done by Shailesh on Wednesday, and if you see this presentation, then you can perhaps refer to him. Sharding has been implemented natively in the Oracle database. So there is actually an enhancement to the SQL code that you can say, for example, create sharded table. There are other things that we have done to the sharding concept. We have PDB sharding, which is specific to Oracle, and we have mid-tier sharding. And in 20C, as you can see, we will even give you a way to not always provide the sharding key, and we automatically will detect what sharding key you are presumably using. Whether that scales linearly, we'll have to see then, but we will give you this option, in addition to a sharding advisor, which will help you to come from non-sharded databases into the sharded world by giving you advice how to modify your schema if you want to do this. Now, the real value add that Oracle has compared to no other database, and I will have only one word on this one, is maximum availability architecture. Why is this a value add? There is no cost with this. This is a set of very rich best practices and blueprints, and those best practices and blueprints will explain to you how to use all of these features that I've named and many, many more in the best way to meet your requirements, to meet your use cases. So if for high availability, a lot of databases have similar solutions to Oracle, we still have more, but in order to use them, we have MAA, and that one guides you perfectly well. And if you want to have more examples, please remain seated for Mauricio. He will walk us through customer cases which have used MAA, MiBanco and Banco de Bogota.
Good. Hi, everybody. I'm going to try to show you 2 examples, 2 customers in Latin America. They have been implementing some of the HA features that we have talking about here. HA, DataGuard, RAC, Farsync that Mark was telling you about it, and PDBs and GTS. I'm going to talk something about GTS. So one of them is MiBanco. That customer is located in Peru. They were running IBM Power, a cluster with 2 nodes, a big node with a lot of the cores running on that system, and a second node with a little tiny number of cores, just 2 cores. The reason why is because they were having a lot of performance issues with the interconnect. That's why it's really important to follow the best practices. As you know, we have a lot of best practices written about how to implement a proper interconnect. They weren't following the best practices. That's why they were reaching a lot of performance issues. So instead of having that cluster, they moved to the ExaCloud.Customer. ExaCloud.Customer has the InfiniBand network, which has 40 gigabits per second. And with that performance, they reduce all the performance issues they were having, and they gain a lot of things, a lot of features, like DataGuard. I will tell you what is the implementation they did on this system. On the production environment, they implemented an ExaCloud.Customer having a proper rack configured with 2 nodes running InfiniBand network, and having a second ExaCloud.Customer using active DataGuard. Why active DataGuard? Because they wanted to run analytics. And analytics was using a lot of power on the production environment. So they decided to move that load into the standby side. That's why active DataGuard was so important, because everything who was consuming resources on the production environment was moved to the standby side. So that's one of the main features that they started using. They didn't have DataGuard, so they were using everything on the production environment. One of the details that we have, because we don't have much time and I want to talk about the next customer, one of the details that we have here is they started using PDBs. They didn't use PDBs before. As you guys know, probably when you use the cloud, you are forced to use PDBs. Okay, if you are running 12.2 up, you have to use PDBs. So instead of having several databases, they consolidated everything in just one container and several PDBs. They started using services. They started controlling the parallelism with services. That's something that you can do when you run services. They started using in-memory, because if you want to run in-memory, you want to run analytics, probably most of the load is analytics. So you need to have in-memory to be enabled for some tables, and that's going to give you a better performance. That's going to help you a lot. And that is reducing, actually, for this customer, all the load from the production environment, and that is being run on the standby, and is running really fast. It's helping a lot, okay? Now I'm going to talk about this customer. This one is going to be a little more complicated, which is actually fun, because they are using a lot of HA products. They are using GDS, they are using PDBs, they are using a standard cluster, they are using parsing. This customer has been using RAC for a long time. The preferred architecture is a standard cluster. They always run every single service using a stress cluster. You know what a stress cluster is, right? This is a cluster, a metro cluster, we call it in some places. So every single system that they have, it runs with an extended cluster using 52 kilometers distance, which is the longest distance that we know, right, Marcos?
Yes.
52 kilometers, which is really impressive. The only thing is, for them was really difficult to implement as well a disaster recovery site, because technically an extended cluster is using 2 sites. But what if you have a human error? What if you have a block corruption? You don't have how to recover without using the backups. So that's why they decided to move to a different architecture and trying to follow the MAA best practices. So let me show you what we have here currently on the production environment. Now they have Exadata Cloud Customer on the production side. They have Exadata Cloud Customer on the standby side. But instead of using just one cluster, but that's not possible with Exadata, they have Active DataGuard. With the Active DataGuard option, now they can use the standby side for reports as well. That helps a lot to reduce all the load on the production environment. And they also have a recovery appliance, as you can notice there. They have a recovery appliance on both sides, and they always try to back up locally, so you can reduce the traffic. Remember, this is using 52 kilometers distance. That's a lot. So that's why they have a recovery appliance on the production environment, and they have a recovery appliance on the standby side, backing up locally. Let's talk about how they moved from one scenario to the other. In the left side, you're seeing how they currently run a lot of the production databases. They use a standard cluster, 52 kilometer distance. They have 3 sites. You know, the best practices always tells you to use 3 sites. One site for the production environment, another site for the DR, and the third site for the quorum. You know, it's always needed, a quorum. We are running an extended disk group redundancy and extended cluster configuration. The reason why is because they needed RPO 0. So it's really known that it's just one cluster. If you connect to one of the sites, let us say the primary site, and you have a failure on that side, the cluster automatically is going to migrate the service to the other side, because it's part of the cluster. And all the sessions are going to fail over to the other part. So technically, I'm reaching the RTO 0, which is good. It's perfect. RPO, that's good. ASM is going to replicate, let us say that. It's going to copy on both sides. So if you have an issue on the first side, everything is going to be in the other side. That's good. But what if we have a human error? What if we have a block corruption? That's going to be difficult. That's going to make me use backups. And with backups, RPO 0 is almost impossible. That's one of the reasons why they decided to move to a next level. And that next level is the right side. As you can notice, Exadata Cloud Customer in the primary side, the same that we have the nodes here. And they have another Exadata Cloud Customer on the right side. And they started using Active Data Guard. The reason why we have the parsing there is very special. As I tell you, they have RPO 0. To be able to complete an RPO 0, you need to have a synchronized replica. That's the only way you can guarantee RPO 0. So that Active Data Guard is using a synchronized replica. But what if the network has a hiccup? Hiccup? What if the network has an issue? Everything is happening. So instead of stopping the production environment, we are migrating or moving from synchronized replication to asynchronous replication, which is good because the production database is going to keep running. The bad thing is, now it's going to be difficult to say that we have RPO 0 because we are not confirming. We don't get acknowledgement that actually the other database got the redo. That's why parsing comes to the picture. Parsing is really important because it's located in the same place where the NFS is for the voting, It's located in the same place, and it's a synchronized copy of the redo information. If you don't know, the parsing is not actually a database. It's just an instance that is getting all the redo. So we also have a second copy of the redo. We are sending the synchronized copy to the standby side, and we also send a synchronized copy to the parsing. If the standby side has any issue, we move that from synchronized to asynchronized, but we still have the synchronized copy with the parsing that is located outside. So technically, we are reaching the MAAA architecture. Why GDS? GDS is on the picture. Sorry, I'm taking 2 minutes. GDS on the picture because this customer knew how to connect to a cluster. Just one scan, just one service. They didn't care about where the service is running. As I connect to the scan, that scan is going to send me to where the service is running. But now I have 2 databases, 2 different clusters, 2 different scans. And they didn't want to change anything in the way they connect. So we put GDS on the picture to accomplish that. GDS is going to be responsible for load balancing and failing over the sessions. How come? GDS is providing a new scan. So we have like 3 scans here. The scan for the production cluster, the scan for the standby cluster, and the scan that we have on the GDS. That scan is the scan that the customer is going to connect to. So I go to the GDS scan. I say, I want to go to this service. And the GDS is going to send you to the primary database where that service is running. And if you have an issue, automatically it's going to run a failover to the standby side, and it's going to move the service to be active there. So from the application point of view, it's going to be transparent, that you have 2 clusters, 2 databases, and it's going to be handled for the GDS. So this is pretty much it, what we have on these customers. This one is pretty cool because, a lot of distance, that's possible. The maximum distance supported is 100 kilometers. This one is a pretty cool architecture. Thank you very much. I think we're running out of time.
Yeah. Thank you.